In this lecture, we are going to study about radiative transitions and the phenomena associated with radiative transitions like absorption, spontaneous emission, and stimulated emissions. This is lecture 1 of unit 3 optoelectronics. Now over here you see the structure of an atom. To understand what is radiative transitions, first we shall understand the structure of the atom. We know that at the center is the nucleus, which is made up of protons and neutrons. And around the nucleus, we have the electrons moving around in different orbits. Electrically, the atom is neutral because the number of protons is equal to number of electrons. This picture shows you the energy level diagram of a discrete atom. They can be numbered as K, L, M, N or 1, 2, 3, 4, so on. So these are the various orbits in which the electron can move. Over here you can see what is the valence band and what is the conduction band. How do you get a band? When we have a single atom, the energy levels are called as discrete energy levels. But when a group of atoms come closer together, they form a solid. And in the case of a solid, we do not have discrete energy levels, but we have got a band structure. That is why we have got the valence band and we have the conduction band. Now, in the valence band, all the electrons are moving around the orbits. That is, they are bound. When energy is given, then the bonds can break and the electron can jump from the valence band to the conduction band. We can see over here what is generation and recombination. When one electron leaving the energy level creates a hole, the process is called electron hole pair generation. Similarly, when an electron combines with a hole, the process is called recombination. Generation and recombination of electron hole pair essentially requires external energies such as optical, electrical or thermal energies. Such processes are mainly between the valence band and the conduction band. Now, we shall see what is the difference between radiative and non-radiative recombinations. Radiative recombination occurs when an electron in conduction band recombines with a hole in the valence band and the excess energy is given out as photon. Optical process associated with the radiative recombinations are absorption, spontaneous emission and stimulated emission. And non-radiative recombination occurs when an electron in conduction band recombines with a hole in the valence band and the excess energy is given out as heat. Non-radiative recombination processes involve Auger recombination, surface recombination and recombination at defects. Now you can see two energy levels over here, a level say E1 and a level E2. And we shall see what are the three processes over here, that is absorption, spontaneous emissions and stimulated emissions. What is absorption? When an atom absorbs an amount of energy h nu in the form of photon from the external agency and is excited into the higher energy levels from the ground state, then this process is known as absorption. You can see it in the first diagram over here. Initially, say the atom is in the ground state. It will absorb energy from an external source and go to higher state. It can go to any of the higher states over here. Here we have seen only one higher state, but there are n number of higher states. And which higher state will it go? It depends upon the amount of energy it has absorbed. What is spontaneous emission? When an atom in the excited state emits a photon of energy h nu coming down to the ground state by itself without any external agency, such an emission is called as spontaneous emission. Photons released in spontaneous emissions are not coherent. Why are they not coherent? Because now the atoms can be in any of the higher energy states and they can come down from any of the higher energy states to the ground state. When they are coming down from any of the higher energy states to the ground state, they give out different amounts of energy. Different amounts of energy means different values of frequency and different values of wavelength. That is why we say that spontaneous emissions are not coherent. The third diagram over here is about stimulated emissions. Now, when an atom in the excited state comes to the down to the ground state with the influence of external energy, such an emission is called as stimulated emission. Two photons of the same energy h nu are emitted. In the two photons, one photon induces the stimulated emission and the second one is released by the transition of atom from a higher energy level to lower energy level. Both the photons are coherent. So in this particular lecture, we have seen what is radiative transitions. Radiative transitions means it gives out energy in the form of photons. And the processes involved are absorption, spontaneous emission, and stimulated emission. Absorption means what? The atoms in the ground state will absorb energy and go to different higher energy states. Spontaneous emissions means these atoms from the higher energy states will come down immediately to the lower energy states. Stimulated emission means what? The atom in the higher energy state is forced to come down when external energy strikes it. In all this, what is important is the stimulated emissions.